Questions from the homework from last day, number 10. Ooh, nice. Wow. Woo. Sheesh. Okay. Let me make it a little bigger so you can zoom in. Number 10. The simplified form of that is, so first of all, here is how I see this. Can you read me the thing that's in the very front of that, Naomi? I don't see it that way. I see a 36 on the bottom and a 1 on the top. And then everything else is on the top. How do I know they're on the top? Because that's technically over 1, then that's technically over 1. And when you're multiplying fractions, it's just top times top. Over bottom times bottom. So I'm going to do that first. Now I'll go through, by the way, I don't think this 1 is going to make any kind of a difference, so I'll ditch it. Do I have a power to a power? I do in the first bracket. So I'm going to rewrite this as 2 squared for x cubed squared, x to the 6th. And then I'm going to have a negative 3, a y, and x squared all over 36. So far, so good? Yeah. Then I'm going to say, you know what? On top, I don't have a 4 and a negative 3. What I really have, yeah? On the bottom, there's still a. And then how many x's do I have on the top grand total? Can you see it? 8. How many y's? Oh, good gosh. You said 8. I wrote y. Why? I don't know. I'm nearly done. Check the numbers. Can I reduce negative 12 over 36 into lowest terms? Yeah, there is something that goes into 12 and 36. 12 does. This is going to end up being a 1/3. Oh, it's negative. That's the fraction number part. And then how many x's do I have left? Where? How many y's do I have left? 1. Where? On the top. That's the answer. Now let's go find it. Oh, can you see, and I've talked to you about how when you write fractions or roots with a typewriter, with a math editor, it tends to put fractions kind of halfway up and halfway down and then everything in the middle. I don't like that. I much prefer that. To me is way cleaner and I understand that way better. Is that all right? Good. Any others? 11, 13. 11. Okay, I said you look for a power to a power first. Is there an exponent on the 6? No, rewrite it. But there's an exponent, so that 2 is going to go onto there and onto there. It's going to be x to the 6th, y to the 10th, because the power to a power rule said multiply. Oh, and I have a power to a power there. I have a 3 to the 4th. I could write 3 to the 4th, but are you at the point now where you know what 3 to the 4th is as a number? What is 3 to the 4th as a number? Don't think so. If not, go to your calculator. We did review how to find our exponent button the other day. Yes. 81. And then, who asked this one? Marcus or Brody? Who asked number 11? Oh, Marcus. And then it's going to be x to the 4th. Yes, Marcus? And y to the 4th. Have I taken care of the powers to a power, the exponents outside brackets? Okay. Now, numbers 6 over 81. I think 3 goes into each of these. I think I can divide by 3, divide by 3. I think I'll get a 2 on top and a 27 on the bottom. How many x's on top, grand total? Well, 6. How many on the bottom? 4. How many left? 2 where? On the top. I agree. How many y's on top? 10. How many on the bottom? 4. How many left?
6.
On the top. Which is that one when they type it. Yes? And someone said 13? No one said 13? Yep. 13. Lucky number 13? Ah, yeah. These are tricky. This would be an example of a really challenging question. Well, first of all, it says simplify. Okay. I think what I really have is something like this. A to the 5th times a to the 6th. Now, if I said that, what would the answer be? A to the 11th. You add them? I think they want us to go a to the x plus y plus 2x plus 3y. That's that's exactly what they want us to do, which is going to be a to the, is there anything in front of the bracket right there? So I can ignore it. Is there anything in front of the bracket right there? So I have x plus 2x. What is x plus 2x? 3 x's. What is y plus 3y? You know what? That apparently simplifies to 3x plus 4y. I suspect the one that's bugging you is C. What are we doing with the exponents? Dividing. Sorry, what are we doing with the powers? Dividing. So what are we going to do with the exponents when your bases are the same? Ben? It's going to be a to the 3m plus 2 take away m minus 3. Is there something in front of the bracket right there? Right there. Is there something in front of the bracket right there? Nope, I can ignore it. Is there something in front of the bracket right here? Ooh, yes, which means that's going to become negative, and that's going to become a minus minus. So if I hear you correctly, I'm going to get this. A to the 3m plus 2 take away m plus 3. A to the 2m, 3m take away m, plus 5, yeah? 3 plus 2. Okay? I'll let you try B and D on your own, see if you can figure it. Let me just double check. Oh, so for D, add, and then subtract. For B, subtract. It'll be x plus 9, take away 3, which I think is x plus 6. And these are tricky. Any other questions? Yeah.
7C.
7C. Nice. Woo! I gave that. Boy, I must have been in a mean mood. Okay. No O, Mr. Duick, just K. Oh, K. First, what is the first thing I look for? Power to a power, exponent outside the brackets. There is one in the first one. So I'm going to clue in that this 2 is going to go on the negative, the 5, the 3, the 2, and the K. I'm going to get rid of those because that really clutters up, but I'm going to keep that in mind. Ben, my friend, what's a negative squared? So I'm going to lose the negative. What's a 5 squared? There's going to be a 25. What's a k cubed squared? K to the 4th. Over on the right, I have a negative k to the 5th. Oh. K squared all over 5k squared. Now here's the nice thing. We have one fraction times one fraction. How do I know times? Because that's what a bracket right there, it means multiply, yes? Multiplying fractions is the easiest fraction operation. It's top times top, bottom times bottom. In fact, if you're really lazy, you can just think about it as saying, you know what, that's your fraction as long as you multiply everything on the top and you multiply everything on the bottom. So, Ben, my friend, let's do numbers first. is my answer going to be negative or positive? Now, I lost a negative right here when it's squared. Is this negative going to vanish?
No.
Somewhere I'm going to have one single solitary negative, which means since I'm multiplying and dividing, Brody, if I got one negative left over, my final answer is going to be negative. Ta-da! Numbers. What numbers do I have on top? No, no, no. What numbers do I have on the top in my blue right here on this line? What numbers do I have on top? 25. What numbers do I have on the bottom? This is 25 over 5. What is 25 over 5? Okay, I took care of the negative already. It's actually negative 25. I took care of the negative. There's going to be a 5 left on the top. How many K's on top grand total? 12. How many K's on the bottom grand total? 4. How many will be left and on the top or on the bottom? How many K's on top? 12. How many on the bottom? 4. How many left? 8. Where? On the top? Yeah. Do I have anything left on the bottom?
No.
Then I'm not going to write it. I could put an over 1. That's a waste of time. Negative 5K. We're going to continue with this, but we're going to add negative exponents today.
Oh.
Yep.
So there's also a negative k to the fifth at the top that you missed?
No, I didn't.
Because the answer is negative 5k to the third.
Oh, I'm sorry. I'm sorry. You're right. I totally did. No, I didn't. How many K's are there on top? Not 12. There are 6, 4, 5, and 7. There are a total of how many K's on top? 17. And how many K's on the bottom? Good gosh, Mr. Dewick. Which means there's 13 K's left over. Is that right?
Yes.
Sheesh. Candy for you later. Lesson 3. Integral exponents. That's the fancy schmancy word for negative exponents. What if your exponent is a negative number? Now, I need to be clear. We're talking about negative exponents, negative exponents, negative exponents, negative exponents. We are not talking about a negative base. We've been dealing with negative numbers since grade 7 or grade 8. What we're talking about is, what if the little tiny number that's written really small, the superscript, the number up there above the base, is negative? So, first of all, we need to review the zero exponent rule. In algebra, it says this: x to the 0 is 1, where x can be any number but 0. Anything to the 0 is 1, except for 0. 0 to the 0 is undefined. Why, Mr. Dewick? Ask me later. Anything to the 0 power equals 1. For example, what's 4 to the 0 power? 1. What's negative 5 all to the 0 power? 1. What's a million to the 0 power? 1. What's a to the 0 power? 1. Hey, look at my clock. What's pi to the 0 power?
1.
That's why that's a 1. Okay. What about c? Is that 1? Negative 5 with a little 0 up there. Ooh, Alex, what?
Negative 1.
Because is that 0 on the negative? No, it is in 5b when I made sure it was in the brackets. This would be drop the negative, and then it would say 5 to the 0 is 1. Oh, there's a negative in front. What about d, 15x to the 0? Brody, what? You want to say 1? Is he right? Where's that 0 on? Is it on the x, the 15, or both? It's only on the x. If it was on both, how would I write this? With brackets. So, Brody, this is really 15 times x to the 0 is 1. And in your head, no calculator, what's 15 times 1, Brody? Did you say 15? I hope you did. If you didn't, you're in trouble. Okay. That's the zero rule. And that leads us to the x to the negative m rule. You saw this last year. Algebraically, you said this. X to the negative m equals 1 over x to the m, where x can be any number but 0. In other words, they'll usually say x not equal to 0. That's how they write x can be any number not equal but 0. X not equal to 0. In English, what does it mean? Here's how I remember this. A negative exponent acts sort of like an elevator. Say what? It causes the term to change levels in the fraction. A negative exponent acts like an elevator, sort of. Causes the term to change levels. Huh? X to the negative 3. If I want to rewrite that as an exponent, technically right now this is x to the negative 3 over 1. If I want to rewrite that, a negative exponent acts like an elevator. If I want to make the exponent positive, I need to change floors. Oh, what am I going to put on the top there? I can't just leave it blank. 1. What if I had this? Where is the negative exponent right now? Bottom. Elevator. Comes to the top floor and becomes positive. Hey, what if I had this? A to the negative 3 over B to the negative 2. Elevator. Elevator. That's how I think about this. Now, please be careful. Please be careful. What if I have this? That is not 1 over 5. That's not a negative exponent. Where is the negative? Upstairs, little tiny number exponent? No, it's in front of the number. Negative 5 is still negative 5 is still negative 5. It is not. Don't do that. That's not an elevator. Hey, what does an equal with a line through it mean?
Not equal.
Not equal to. Let's try a couple. It says evaluate. And we're going to see if we can do some of these without a calculator if they're numbers, because this would be some of the stuff they could throw on the non-calculator section of the provincial. 4 to the power of negative 3. First thing I always check for is a power to a power. Is there an exponent outside the brackets? Nope. The next thing I deal with are negative exponents. Is there a negative exponent? Yeah, elevator. Right now it's on the top. Put it on the bottom and make it positive. Oh, what's left on the top, by the way? It's invisible.
1.
And as a fraction, without a calculator, I can evaluate this. This is 1 over 4 times 4 times 4. Are you starting to memorize some of the smaller exponents? What is 4 to the third power? No calculator, Anthony. 64. B. Negative 2 all to the negative 3. Is there a power to a power? Well, you could argue there's an invisible 1 there. I'm not going to freak out about that. I'm going to say, you know what? This is a negative 2, all of it, to the negative 3. I don't think there's really a power to a power. Is there a negative exponent? Elevator. This is going to be negative 2 all to the positive 3, and there'd be a 1 left on top, which is going to be a 1 left on top. What is negative 2 to the third power? Garrett? I agree. That is correct, but in math, it's bad math manners to leave a negative in the bottom of a fraction, just like it's bad math manners to walk around with something hanging around from your nose. It's not illegal, no law against it, but if you want friends, you'll probably deal with it. If you want math nerdy friends, the negative goes on the top or in front. Also, if I'm marking, that's where I'll look for the negative. I might miss the negative if you leave it in the bottom. So you might lose marks that you shouldn't. Mr. Dueck, why doesn't this negative become an elevator and move to the top? Is that negative an exponent? Then don't do that. C. Elevator. Over 1. D. Elevator. Elevator. And the key, Curtis, to remember is when you do the elevator thing, make sure you ditch the negative. I can also, by the way, reverse this. I can say, write this with a negative exponent. If I said 5 over 4, you could write that as 4 to the negative 1 over 5 to the negative 1. I can bring in negative exponents if I need to. I don't do that very often. I don't like negative exponents, but the elevator rule works backwards too. Okay, what if you have a fraction to a negative exponent? Now, they wrote this. A over b to the negative m equals b over a to the m, where a and b can be any number. I usually just do this. I would go a the negative m over b to the negative m, because didn't our power to a power rule for brackets for fractions say that it goes on the top and the bottom? And isn't this here exactly like we just did right there? Alex, yeah? Which would give you elevator, elevator, which is what that is saying too, by the way. I just find memorizing or adding an entirely new rule when I can derive it in one line. You can. I really just flog the elevator metaphor to death. Let's do some examples. This is going to be 5 to the negative 2 over 4 to the negative 2. Power to a power. The rule we used last day. Oh, elevator. What's going to be on the bottom here? 5 to the power 2. Can I evaluate that? Yeah, you know what? If you in one step say, woohoo, 25, I say, woohoo, good. And what's going to be on the top? 16. B. Is there a power to a power? Yes. We'll deal with that first. There is an exponent outside the brackets. The negative there, will it stay? This negative right here, will it stay or will it vanish? And how do you know? Why will it stay? Yeah, you know what? The exponent's odd, even though it's negative. The exponent's odd. I'm going to have an extra negative kicking around. So, Alon, what I'm going to do is I'm going to say to myself, look, I know this. Yay! I wrote something down. It's no longer blank. And I would have 2 to the negative 3 all over 3 to the negative 3 if I use my power to a power rule. Now what? Is there an exponent on the negative? No. Leave it. Is there an exponent on the 2? Yes. What? Elevator. Have we taken care of everything on the top? Yep. Let's go down to the bottom. Is there an exponent on the 3? Yeah, what? Elevator. Would I leave my final answer like this? Negative 27 over 8. C. Why is it 4 to the third? Because a negative exponent acts like an elevator. Except 4 to the third, Greg, I think is small enough that I can evaluate that too. What is 4 to the third? Positive 64. Yoink. It says, simplify, express with positive exponents, and evaluate. Now, I mentioned last day, I'm not a big fan of this as a division sign. I much like to see a fraction. Why do I like to see a fraction? I like to know what's on the top and on the bottom. So I'm going to actually quickly rewrite this, Brody, as 4 to the 5th divided by 4 to the negative 3. Is that the same question? Why do I like that? Because now I can clearly see my approach. Is there a power to a power? Is there any exponents outside the brackets here? Nope. Are there any negative exponents?
Yes.
Elevator. Let's go one thing at a time. 4 to the 5th stays where it is. 4 to the 3rd comes to the top.
4 to the 8.
Nothing left on the bottom. Now, you could have got there in one step, I agree, Anthony, by saying, oh, we're dividing, and so you subtract the exponents. It's going to be 5 minus minus 3. How often do you think kids miss the minus minus and go 5 minus 3 and tell me the answer is 2? It drives me crazy! So, Alex, I just choose to say, write it as a fraction and then elevator before deal with negative exponents, because if we're going to make dumb mistakes, it's going to be with negatives. If I was doing B, I would say, oh, for Pete's sakes, this is really 3 squared over 3 to the negative 5. I would say, this is really 3 squared and elevator 3 to the 5th over nothing. Well, over a 1. Am I going to write the over a 1? No! What is 3 squared 3 to the 5th? Simplify to. 3 to the 7th? Yeah, Whatever the heck that is, I don't care. C. Is there a power to a power? Is there an exponent outside the brackets? No. Is there a negative exponent? Elevator. 2 to the, I've done the elevator, get rid of the negative, positive 5. And I think 2 to the 5th is 32? 2, 4, 8, 16, 32. Yeah, it is. D. Now, you could do this by saying, well, my bases are the same. I'll subtract the exponents. So it's going to be, you're opening yourself up, Jordan, to lots of minus errors, lots of sloppy errors. You know what I'm going to say, Jordan? Is there a power to a power? Check, is there?
No.
I'm going to elevator. I'm going to quickly, because it takes 1 second, rewrite this as there's a 6 to the 7th on the bottom and a 6 to the 5th on the top. Jordan, how many 6s on top, grand total?
5.
How many on the bottom, grand total?
7.
How many left and where? 2 left, where?
On the bottom.
Yep. Am I going to leave my answer like that?
No.
What am I going to put on the top? I think that's a way easier way of thinking. Elevator first, and then how many on top, how many on the bottom. I think that's a way easier way of thinking than doing it this way. 6 to the negative 7th divided by 6 to the negative 5. That's going to be 6 to the negative 7 minus negative 5, because you subtract the exponents, which is going to give you 6 to the negative 7 plus 5, because the minus minus is a plus, which is going to give you 6 to the negative 2, which is then going to say, oh, that's an elevator I'm going to suggest my way, less writing, 2 lines, cleaner, and you're avoiding the whole minus, 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 minus garbage. Oh, you know what? We can tidy this up one step further. Jordan, what is 6 squared? I think we'd probably write that answer like that. Yeah? If we can do the exponent in our head, let's do it. Oh.
Why do you times 2 but not 3?
What do I times, sorry?
Why do you make it 3 squared to 3 to the 5th? Why do you times those 3 times 2?
What do I times those?
You're adding the exponents in there. You're leaving A and B as powers.
Because when I took care of my negative exponent, it ended up on the top and became positive, yes?
Yeah.
So now it is going to be times times, we're going to add the exponents. Here, when I did the elevator, this guy moved to the top, this guy moved to the bottom. So now it's still dividing, and the easiest way to do the dividing is to say how many on top, how many on the bottom, what's left and where. Is that all right? Yeah? Good question. Great question. Hey, let's do a fraction. Sure. Is there a power to a power? Is there an exponent outside the brackets? Then deal with it. It's going to go on to everything inside the brackets. It's going to be a 3 to the negative 3 over a 2 to the negative 3. Then I deal with negative exponents. Are there any? Yep. It's going to be a 2 to the 3rd on the top and a 3 to the 3rd on the bottom. Yeah? You know what? I can take this a little bit further. What is 2 to the 3rd? Yes, 8 over 27. No calculator required. F. Is that negative 3 on the negative in front? Greg? No. So you know what that means? That means there's going to be a negative kicking around because it's not being changed. And what I have then, Greg, is 5 to the negative 3. 5 to the what? Say it again. 5 to the what? Did you say negative? Elevator. That's the same as the 5 to the 3, but on the bottom. Oh, am I going to leave the minus sign sitting up there all by itself with nothing up there? Oh, put a 1 there? Can I do 5 to the 3rd in my head? You know what? I think they'd probably write this as a negative, a 1, and on the bottom, 125. Or I can give you stuff with variables, which I think actually makes things easier. See, I look at A. A says x to the negative 5 times x to the negative 3. I mean, yes, again, Alex, you could add the exponents. You could say it's going to be negative 5 plus negative 3, which is negative... Alex, is there a power to a power? Are there any exponents outside of brackets in A? No. Are there any negative exponents? Elevator. This is really an x to the 5th with a 1 times an x to the 3rd with a 1. How many x's on top? It's a trick question. None. How many x's on the bottom? Grand total. How many left and where? 8 on the bottom. And a 1 on top because I got to put something there. B. Anthony, can you read B to me? I don't like the way it's written. I much prefer a fraction, so I'm going to go like this. A squared, 8 to the negative... Isn't that still 8 to the negative 5 divided by a squared? Now, why do I do that? Is there a power to a power? Is there a negative exponent? Well, an elevator. Let's see, this a to the 5th is going to end up on the bottom. There already was an a squared on the bottom, and it's not a negative exponent, so it doesn't go for a ride on the elevator. What would I put on the top here, Amber, just sitting there? A 1. And, final answer, how many a's on top? None. How many a's on the bottom, Amber? How many left and where? 7 on the bottom. Yeah? with a 1 on the top. This is how I've been doing exponents for years. Never seen it in a textbook, but it really works well for me because it avoids the sloppy mistakes. And Ashley, most of the time, it's less work for more bang. Not always. There's a couple where it's more work. C. A to the negative 5 times a to the negative 5. Yeah, you could add the exponents and you could say it's a to the negative 10, but now you're still stuck with a negative. For Pete's sakes, is there a power to a power? No? Is there a negative exponent? Well, then you know what? Let's write this as over elevator and over elevator with a multiplication in the middle still. Oh, Garrett, what would I put on the top of each fraction? Okay. Can you see it? How many A's on top? None. How many A's on the bottom, Garrett? 10. Can you see it's going to be a 1 on the top and 10 A's on the A to the 10th on the bottom? My method really shines when we look at D. See, if you use the subtraction rule for D, you would say, oh, I subtract the exponents, I'll go 3, take away 9, I'll get x to the negative 6, but I'm not done yet. Where with my method, we can go straight there. How many x's on top, grand total? How many on the bottom, grand total? How many x's left and where? No work shown. I like that. Let's build this up. Do you see a power to a power? Okay. See any negative exponents? Then let's take care of them. Now all we're going to do is we're going to move from left to right. If it doesn't have a negative exponent, rewrite it on the same level. If it does have a negative exponent, put it on the elevator. 3 stays. X cubed stays. What's between the bracket and the bracket sitting right here? What mathematical operation is right there? So I don't want to use a times symbol because that looks like an X. I'll put a dot. 5 stays or goes?
Stays.
X to the negative 2.
Goes.
Elevator. Can you see it? I think now we can go straight to the final answer, Amy. Numbers. What do you have for numbers on top, Amy? Can you see it? More specific, because they're being multiplied. What does that work out to? There's 15 on the top. Any numbers on the bottom? So I know there's a 15 on the top. Letters. Amy, how many X's on top, grand total? How many on the bottom, grand total? How many left and where? 1 left where? On the bottom? On the top? Which one? How many X's on top, grand total? 3. How many on the bottom, grand total? So where do you have more X's? So how many are left? 1. Where? Yeah, why? Where do you have more X's? So that's where there's going to have the extra ones left, are you not? Yeah. In other words, it's going to be, the 15 was on the top, there's going to be an X right next to it. Is anything left on the bottom? A 1. Am I going to write it? Oh, sorry, did I get you with that? I'll really work on you. F. What's the first thing you check for?
Power.
Power to a power. Is there a power to a power? Next thing I check for, Naomi. Negative exponents. Are there negative exponents? Well, then let's deal with them. Here we go. First thing I see as I read across from left to right is a 2. Does it stay or does it go on the elevator? Then rewrite it. The next thing I see is an x to the negative 3. Does it stay or does it go on the elevator? Yoink. And becomes positive. By the way, when you put it on the elevator, don't forget then to ditch the negative. The next thing I see is a negative 4. Stay or go? Stay. Yeah, a lot of kids want to make it go. No, because they get it confused with a negative exponent. A negative 4 is not a negative exponent. In fact, the exponent is a positive 1. Curtis, I'm just going to rewrite it. I'll just put it in brackets because it's multiply. Then I see an x squared. Stay or go? Stay?
Yes.
Final answer. Let's see. Numbers. I have a negative 8 on top. Any numbers on the bottom?
No.
Okay. Negative 8. How many x's on top? 2. How many x's on the bottom? 3. How many left? 1. Where, Amy? How many x's will be left? 1. Where? Are you saying on the bottom? It's hard for me to read your lips because you're... Yes? You'd be right. 2 lines of work. We're good. Oh, let's kick it up a notch and a half. Next page. Woo-wee! These look tougher. They're not. They're longer. In fact, I'm going to argue we can do most of these in, count them, 2 lines. You ready? First thing I look for is a power to a power. Is there a power to a power in G? Are there any exponents outside brackets? No? Then let's walk through here using the elevator. Here we go. The 8, stay or elevator?
Stay.
The x to the negative 2, stay or elevator?
Elevator.
Drop it down. The a to the negative 3, stay or elevator?
Elevator.
Drop it down. Then I move to the bottom. The 2, stay or elevator? Stay. Can I put the 2 in front because that's where it was originally? We're used to looking for it there. Then I see an x to the negative 5, stay or elevator? Move it to the top. Then I see an a to the negative 7, stay or elevator? Numbers, 8 over 2. Hey, what if it was 2 over 8? Where would the 4 be? On the bottom. Okay, so I can deal with it. It's a fraction, not that big a deal. 4 on the top. How many x's on top, grand total?
5.
5. How many x's on the bottom, grand total? 2. I heard the final answer. Brody, how many left and where? Yeah. And do you notice, Brody, you're right. You can almost do it in one fell, like glance, right? Good. Hey, Brody, how many a's left, grand total, and where? Yep. The only thing I might say is I would probably put the a in front of the x because I'm used to writing things alphabetically, but good enough. How many lines? 2. Took us 2 lines. H. Yoink. Is there a power to a power? Nope. Okay. Elevator. Y to the 6. Stay or move?
Stay.
2. Stay or move? Y to the negative 5. Stay or elevator?
Elevator.
Final answer. What's on top? What's on the bottom?
Y to the 11th over 2.
Oh, I can hardly wait to do I. Look at some of these. Wow! Ready? Is there a power to a power?
Yes.
Okay. So here's my strategy. The ones that don't have a power to a power, I'll just rewrite them where they are as is. The ones that do have a power to a power, I'll take care of that. Then my second line, I'll elevator. And hopefully my third line I can solve. Let's see. So I'm going to rewrite in brackets the x to the 4th, the y to the negative 3, and the z to the 5th. I'm going to have an x to the negative 6, yes, because power to a power I multiply. A y to the 12th, a z to the negative 6, close bracket. Why is the first one negative? Because I'm stupid and can't read? Thank you. This first bracket on the bottom is power to a power, so there's going to be an x to the 8th, a y to the 20th, a z to the 4th. And then I'll have, also power to a power, an x, this will be a negative 2, yeah, because it's 1 times negative 2. A y to the negative 2 times negative 2, positive 4. And a z to the 3 times negative 2, negative 6. Have I taken care of all the powers to a power? Then start walking across from left to right, starting at the top. Leave it or elevator. X to the 4th, leave it. Y to the 3rd, negative 3. Let's try drawing that fraction line a little better, Mr. Duke. Y to the negative 3, elevator. Z to the 5th, leave it. X to the 6th, leave it. Y to the 12th, leave it. Z to the negative 6, elevator. Now I'm on the bottom. X to the 8th, leave it on the bottom. Y to the 20th, leave it on the bottom. Z to the 4th, leave it on the bottom. X to the negative 2, move it to the top. Y to the 4th, leave it on the bottom. Z to the negative 6, move it to the top. Shouldn't x, y be to the positive 4? Where? What? You need to be more specific because I got a whole bunch of stuff kicking around. Right here? What's the exponent on the y? On the x? It's invisible. A 1. So 1 times negative 2 would be an x to the negative 2. Yes? Negative 2 times negative 2 is positive 4, which I think is that where that 4 came from right there. I think I'm right. Yes? No? Yes? Yes?
Yes.
I hope. All right. Now the fun part. How many x's on top grand total? Can you see it? I see 4, 6, and 2. Do I not?
Yep.
12 on the top. How many x's on the bottom? Grand total. 8. 12 on top, 8 on the bottom. How many left? And where? 4 on top. Yes? Psst. How many y's on top grand total? 12. How many y's on the bottom grand total?
27.
27. How many left? And where? 12 on top, 27 on the bottom. Do the math.
15.
15 on the bottom. How many z's on top? 11. How many z's on the bottom? 10. How many z's will be left and where?
1 on the top.
Look at what we did. 3 lines. Almost 2 lines. Otherwise, this would be a lot of work. So what's my method, Alon? Deal with power to a power first. Elevator. And then simplify. Garrett, you going to make it? We've got a couple more. Hey, what if they have negatives on ground level, not just as exponents? Oh, like J, we got some negatives kicking around. Okay. I add one thing first. Before I do my power to a power, if there is negatives kicking around, I ask, do they stay or do they go? So you ready? There's a negative right there. What's the exponent on that negative right there? Even or odd?
Even. Oh, it's 7.
It's not a 7. That 7's not on the negative. If it was, that negative would be in brackets. The exponent acting on that negative is that bad boy right there. So here's my question. Will that negative stay or go?
Go.
Then you know what? Let's scribble it out. How about, because it's going to go, it's to an even power. What about this negative here? What's the exponent on this negative here? Not this 2. What's the exponent on this negative here? Huh? 2? Will that negative stick around or vanish? I heard stay, I heard go. Convince me that someone's wrong and someone's right. Which one? Negative squared is going to be gone. What about this negative right here? What's the exponent on it? It'll stay. What about this negative right here? What's the exponent on it? It'll go. Oh, I have one negative. What's my final answer, negative or positive? See, we can work it by a process of elimination. And that gets rid of that issue. By the way, if this was a multiple choice question, you know half the answers would be positive, half the answers would be negative. You've just got rid of half of the wrong answers. You've turned it almost into a true-false question. Right? So I know the answer is going to be negative. All right. Power to a power. I'm going to have x to the negative 28, y to the positive 8, yes. Z to the positive 8. In the second bracket, I'm going to have x to the 4th, y to the 8th, z to the negative 4. Yoink. All over. I took care of the negative already. X to the 6th, z to the 3, y to the 4, z to the negative 6. Am I right? We're one line from being done. Elevator, and we're good to go. Let's see. First of all, we said my final answer will be negative. Let's rewrite that guy. X to the negative 28. And make it positive. Y to the 8th stays. Z to the 8th stays. X to the 4th stays. Y to the 8th stays. Z to the 4th, move it down, baby. X to the 6th stays where it is. Z cubed stays where it is. Y to the 4th stays where it is. Z to the negative 6. Aha! Elevator. My final answer. Negative or positive? Boom. How many X's on top? I see 4? Yeah? How many X's on the bottom? I see 34. How many X's will be left and where? I think 30 on the bottom. Sorry, I was making these up. The numbers are getting a little bit big, but still dealable. Let's do the Y's next. Why? Because. How many Y's on top? 16. How many Y's on the bottom? 4, I think, yeah. So 16 on top, 4 on the bottom, 12 on the top. Yo.
I'm not sure if this is correct or not, but on the bottom, wouldn't 28 plus 6 equal 34, not 30?
Yeah, but how many X's were on top?
Yes.
4 on top, 34 on the bottom. Leaves me 30 left on the bottom. Yep. Hey, we've done X's, we've done Y's. What usually comes next? Unless you're an American, then it's Z's. Yeah, here we go. How many Z's on top? How many Z's on top?
14.
14. How many Z's on the bottom? 7. 14 on top, 7 on the bottom. How many left and where? This is almost fun, Mr. Dewick. Let me see here. Let's skip K. Let's do L, because L is similar to K but yuckier. So we can get L, we're in good shape. This is putting everything together. Here we go. Are there any negatives on ground level kicking around? Are there any negative numbers or negative X's? Garrett's nodding. Let's take care of those first. So Garrett, my friend, the first negative that I see is this one. The exponent on it is that guy. Will that negative stay or go? Gone. The next negative I see is this one. It's going to stay, which means my final answer is going to have a negative kicking around. And I put that on the top or in front. Now let's go power to a power. I'll have a 3 to the negative 2, an x to the negative 6. By the way, what is y to the 0? What's 0 times negative 2?
0.
Still y to the 0. You know what? It's still a 1. Do I really need to bother writing that 1? Skip it, I say. Z to the what? 8 over, we already took care of the negative. 6 to the negative 3, x to the negative 3, y to the positive 9, z to the negative 3. Yeah? All right, smarty peoples. Elevator. Leave the negative on the top. 3 to the negative 2. Stay or move? Becomes a 3 squared. X to the negative 6. Stay or move? Z to the 8th. Stay or move? 6 to the negative 3. Move? X to the negative 3. Y to the 9th. Z to the negative 3. Move. Let's tidy this up a little bit. I got a number. Dunk. I got a negative. I got in the front, there's going to be a 6 to the 3rd. I don't know that one. I think it's 216, but someone double check me. Is it? Yeah? 216. How many x's on the top, grand total? 3. How many x's on the bottom, grand total? It's going to be 3 left on the bottom, yeah? How many y's on the top, grand total? None? How many y's on the bottom? How many left? Where? How many z's on top? Careful. What have I missed? What haven't I covered yet? Do you see it? Yeah, I haven't covered. There's a 9 down here. Oh, you know what? I got a negative 216 on the top and a 9 on the bottom. I wonder if those will reduce. Can someone see? Does negative 216 go into? Does 9 go into negative 216?
Yes, it does.
What?
24.
Final answer? Negative a 24. Z to the 11th. X cubed. Y to the 9th. Okay, 4 lines. Still not that bad if you're careful and systematic. And these are already like far tougher than the average questions we're going to throw at you. Unfortunately, well, I'm going to give you 15 minutes to work on this. You are going to have a little bit of homework for your long weekend. Sorry. What's the homework? So your homework is this lovely sheet called Assignment 3. Which questions am I going to assign? All of them. No, I'm not going to do that. Okay? I think you can try number 2. So you got this thing in front of you, Garrett. You're going to circle the questions I'm assigning. Stay with me here. Here we go. I think you can do number 2. I think you can do 4A, C, E, F, G, and I. So odd letters. Evaluate the following without using a calculator. Let me see. I'm going to pass on 5 and 6. try 9, A, C, E, and G. We'll go 10 all. Oh, cool. How about 11 A and B? 10 all, 11 A and B. 12 is fair game. Skip 13. Wow. Right now I'm not, but maybe, you know what? Instead of, I was going to look at some of the nasties from 14. Instead, I'm going to say, let's try 13, E, and F, the nasties there. Okay? I did attach the answers. If you get stuck. You got 12 minutes, well, no, you got 15 minutes. I think you can get a big chunk of this done in class, if nothing else.